Yeah, I request whoever is the chairman of this session to cut me short whenever if I'm. Yeah, my teacher. So, yeah, I know he is even at times ruthless. That is really nice about him. Right? I'm,
Thank you very much, organizers, to making me embarrassingly achievable. Okay, thank you very much. The first setting is actually begin, the beginning with the plenary talk by Dr. A. Venkatraman, who I know for the last 40, 50 years almost. It so happened his father was my teacher also. He was also chemistry person. And I have been seeing him for the last 40, 45 years, the growth of him. I can't explain it, the growth, but you can see him. And he has contributed a lot in the science. Not only that, popular science and mentoring many of the students also. That is also important thing. And today's talk of him is on the chemistry and physics of high energy materials, a new dimension in material science. This is one, probably the participants here, they will be very happy to listen to him. This is not there in our syllabi. This particular topic is not there in our syllabi, nor anybody is talking, but the India is known for that one, and that he will tell you what is these high energy materials. Though we are doing some research on in a passing way, but how it impacts society, how it impacts the country, other world, so that he will give in a very nice way. So kindly restrict your talk. Thank you. Go ahead. Go ahead.
thanks a lot. The Honorable Chairman, my Guru, Professor Rane sir, uh, all the very distinguished members, and I start my talk because let me be slightly brief. Of course, as Rane sir has told about chemistry and physics of high energy materials, this talk being, innovation for conference being innovation in science and technology, and also being this in plenary lecture, I thought that I should make my talk not an subject oriented or focused to a particular theme, but it will be a slightly broad based. And also this talk being from innovation to incubation, incubation to entrepreneurship, entrepreneurship to business, business to marketing, marketing to development of science and technology. Because I'm also fortunate that there is one Japanese scientist who is going to speak on physics of high energy materials. So I'm going to talk on only chemistry of small aspects. Right? That will be only a small part. I will make this talk a generalized one, and this generalized one will cover my works and the way I have been involved with, the way your the Mannina Maga, Ravi is involved with, the guidance I got from Raja Sahab sir, Rane sir especially, and from the Gulbarga University and all. Right? So if you just click on that, right, what does that resemble to you? Just this is to alert all of you, but this is high energy material, right? It is an atom bomb. It is a bomb, chemical bomb, right? Which makes you activated. Some part of the lecture will be that. The sound is for activation. Second most important thing, before I go into my next part of the talk, and why I am going in for this particular slide, along with the next part of the talk, right? We'll go to the next part here. I am highly indebted, and I am fortunate also to take the permission from Professor Raja Saab to dedicate this talk to him. He has been a guiding force. This slide, I will come to this slide after some slides because this was a dedication slide, so I put it here, but exact thing I will come over later. This is one of the publication under his mentorship. We got 825 today's date citations. And this is the first paper in all the universities, state or private universities, working on nanomaterials using fungi. So thanks a lot, sir, for your kind encouragement and the way it has brought out, right, the recognition it has given. we go over now to our slides. Yeah, the abstract will be on different types of this one. It will only be a gist. I will not, share with you all those equations and all, right? Advanced things of, understanding the theory and all. We will go into the actual things to some extent. Shall we continue further? The continuation of innovation. Innovation starts from ingenuity, intuition, person's thinking, approach, attitude, right? We start seeing how a Stone Age man goes over to the next slide of, okay, it goes over to the development. The development side I have not kept because many of you, starting from Raja Sahab to all, have spoken about the development. Nayak sir also has spoken very clearly about the development, so let us see. If I want to learn chemistry, let me tell you, whether I want to learn chemistry, physics, mathematics, biology, engineering, if I understand the movement of electrons from oxidation reduction, that's sufficient. Movement of electrons, even a whole subject like applied electronics has come out from the electrons. Raja Sahab sir has told about spintronics, where the electrons spin from here to the universe, it can communicate. Right? So that's the most beneficial thing, if we can understand the movement and mobility of electron, I can understand possibly in the different directions. So we'll start taking one by one examples. Right? You know about oxidation reductions and all. Right? Second thing is about how we have to think, because I will come also to ideas with how we need to think about when we are going in for different subjects. First thing I will take, because I have to take you to nanomaterials. Before that nanomaterials, it starts with the nature, where we start seeing the result, or even GCOs also, climbing the walls vertically. And they can even hang down vertically also. We were telling the result creates vacuum, releases vacuum and goes. It is not that, because you can see the site of that one having hairy structures. It has a secondary bonding. In our chemistry, we say primary bonding to be very strong. Fine, good about it. But the secondary bonding plays a vast majority of work. Recent Nobel Prize on metal-organic frameworks went over to the secondary bonding. This is also an act of secondary bondings. Right? We go over to another thing which I want to share with you here is on super adsorbents. I wanted to actually have an this demo. Tomorrow Ravi is going to show you this. Actually, there was a slide, showing, there's a 5 ml beaker and a 500 ml beaker. Right? I have not put it here, but this if I can pour 500 ml in 5 ml beaker, is it possible? Right? We say that 5 ml, 500 ml, how can I pour 500 in 5 ml beaker? It's not absolutely possible. But we have that one in a different way, where we see that these super adsorbent polymers, 1 gram is sufficient. Tomorrow you will be showing. It can take in 500 ml. It can take 1000 ml. It can retain water. Right? These are polyacrylides. You can see that a 3-dimensional structures and all. So this is one way of understanding, innovative thinking which comes over into practice, actual practice, right? So you think and you practice it. This is one thing. Shall we go to the next if there is anything? Yeah, you will be seeing this is how the polyacrylate is. Similar thing if you see about the car tires, right, which is a nylon fibers, right? That makes the difference. This is also again a secondary bond being formed. What you have in APS polymers is when the tire moves over on a road which is having bumps and this one, it expands itself and contracts so that there is a smooth motion. I'm just giving small examples, some examples, and then we give the particular application of it because it's vast enough. The bottle you will be seeing tomorrow again, which is this one. Yesterday I was talking with Sampath Kumar sir. He was telling about the natural adsorbents from menthe seeds, how we get the natural adsorbents, which can even adsorb 500 times, 1000 times he was telling. Same thing we see in the chemicals. And where we use them in bandages or napkins and all. Remember, this adsorbent is not like sponges where it takes in and oozes it out. No, it has to retain. Whatever with the mechanical stress and strain given by the child or by the youth, it has to be retained. That liquid should not come out. So that's what the three dimensions are given. Second thing is, next slide is, Yeah, that's how we can make use also for, discharges and all, urine discharges. That thing, before going here, right, because of the time restrictions, I had to cut short slides, but my interaction I will not cut short. Suppose, this is small out of the box thinking, right? Suppose I have a plate, in a plate, some rice seeds, full of rice seeds, and rice grains in fact. How much time it may take for me to count the number of rice grains? Right? Maybe 100 grams rice grains. How much time it may take? One may tell 1 day, 5 days, 6 months, like that. If I say it takes 1 minute only for me to count the rice grains in that particular place, it is believable? Certainly it could be believable if I tell you. Right? Take some 5 or 10 rice grains, count them within few seconds, take the weight of it, then take the weight of the plate and then divide by it, you will get the number of grains. When a professor or the teacher goes over to teach polymer chemistry, the first principle is that number average molecular weight comes in. Right? He or she may put this particular question and ask you to bring it out like this. Right? If, out of the box thinking, if I ask our student friends that, I am taking 1 kg of sugar, 1 kg of salt, 1 kg of idli, which one is having idli? The eatable. Which one has the highest weight? Out of the box thinking. 1 kg all. Because time is very short, I had to go further. Is it a very difficult question? It is all same, no? 1 kg is 1 kg only. I have told a hint. Out of the box thinking. 1 kg idli will be more. Why it will be more? Because with idli, you will be having chutney and sambar. So it will be more. So our ideas, thoughts should be out of the box. Just not go into a focused direction. This is where, one more, you have heard of this rib caps. Rib caps are the one where, it is just like, example we were telling with Ravi and all, walking over water. How do we walk over water? Water is a lighter medium, and if I have to walk over water, I will have to make a local densitized points where the vase moves over. Right? It rotates the water at that particular local spot, densitizes it, so that the density increases, and density increases, it can walk over. This is what happens even with the real this one also, the caps, right? Caps are, not like a helmet and all, heavy and all. Only on impact, it becomes strong enough, right? What we want a helmet, when we are going to use helmet, or what is the significance of helmet, when there is an impact, it has to become very strong. So that's what the rib caps do. You don't try with it, you don't have the rib caps. Rib caps is, they are having the silica gels, and on impact it becomes strong and hard, which you have seen earlier, where the person even, fell down on the floor and all. Nanomaterials have different sizes. What are nanometers? Don't worry about it, right? Nanomaterials are the ones which are having, right, nano-sized dimension. What Ravi and all have worked on. Because he has worked, because, he belongs to this space, because I have been blessed with Raja Sahab and all, right, their ideas, I am putting certain things here, right. We'll touch on 2 or 3 things, because I had to take you to innovation, I had to take you to incubation, I will have to take you to business, right, and actual business I will have to take you, not the business models and all, what actually the scientists can do. Right? Because the challenging thing, as Nayak has pointed out, we are having less number of students for the science, what we can do. Right? So you can see the fascinating colors. Right? What is the importance of colors? Which Ravi and others have found out, that once the color is strong enough, right? Why nanometers are so very important is the colors are very strong, high intensity. What we mean by intensity? You have a UV curve, no? Absorption versus lambda. If absorption is high, you have a strong intensity. Of course, surface plasmon resonance is there and all, that's what it counts. But this intensity, because with a small amount, it can find out the cancerous cell. Otherwise, to determine the cancerous cell using organic dyes and all, you need not, cancerous is not at the neoplastic stage, but you need at a very high stage, grown cancerous cell. Right? So in situ, it becomes a challenging thing. But this, because it can interact and its influence is a radii. It is not only a spot influence, it influences a radii. You can detect where the cancerous cell is. It is a key and lock and a key arrangement type. Gold and silver play a very excellent role. right? And more important, the simplest thing is gold and silver nanoparticles formation can be seen by just a simple UV visible microscope. More I will not tell anyway, Ravi is there to tell. Shall we go further? Shall we go further? Yeah, this is where, Raja Saab's idea and thought has come. That is why I take the pleasure in, dedicating this to you, sir. Idea of fungi. Of course, somebody at the NCL used fungi oxysporum, Fusarium oxysporum. Why not we have something very more specific? Came to his thought. We worked on Fusarium semitactum. It releases an enzyme, reductase enzyme. The enzyme reductase should reduce Ag plus to Ag0. That's the simple thing, right? And it does the work. We got it in MRV and Elsevier publication of good standing. Plus, it keeps on. Of course, remember, one more thing is, out of 825 publications, our own citations, right? If I say, hardly 10 or 15, 15 may be the maximum. Rest 810 citations are from abroad only, or others rather, not ours. Okay, shall we go next, please? This is about the nanomaterials. Okay, these things will come back, I'll have to go to innovation, so I will not talk much about it. This is what, mushroom, no? Mushroom was your thing, right? He brought out excellent paper on mushroom, right? And you can see that, of course, there is no this one. It's not just, it is left at a nanometer stage, because I told innovative ideas come. Innovative ideas come from persons like Raja Saab and others who have a thought that innovation, we convert innovation to experiment. From experiment, we have to go over to incubation, where it goes over to actual materials, that is actual trials in the industry, where you see the zinc nanoparticles were also synthesized and it goes into this one. Of course, SEMs and all, because I wanted to keep this talk for the children, so I am just avoiding more of the other end science. Right? Shall we go further? This is where. The first slide you saw on having an this one, energetic, this one, sound coming out, is that way, see, in chemistry, you have seen chemical reactions, right? By heat, chemical reactions can come out. Even by cooling also, you can have a chemical reaction, right? High pressure, you have a chemical reaction. You can have a chemical reaction by interacting with other molecules. But this is a chemical reaction which by impact, there is a chemical reaction, right? And that chemical reaction is vast, high energy. See the molecules, so beauty of the chemistry molecules, they retain very high energy. If you induce a NO2 group, I will show you this, all the molecules have NO2 groups there. If there is a NO2 group, the molecules get energized. You have heard of RDX, you have heard of HMX. I will show you Cl20 also. Right? I will show you other molecules. Right? Recently you have heard something in Delhi and Jammu and Kashmir, where they had an explosive ammonium nitrate. Ammonium nitrate per se is not an explosive of that this one. They mixed it with a primary explosive, right? TATP, triacetone, triperoxide, having oxygen in the side chain. Side chain, carbon itself is strong, what you are seeing. Side chain nalli oxygen idare ಇನ್ನೆಷ್ಟು ಇರುತ್ತೆ, right? But remember, to just share the small experience because of my association here, it's very easy to destroy an explosive. Just pour water over it, is over. Right? Because these are ionic compounds. If you have RDX, nothing happens because molecule, this melting point itself is 200. Nothing happens if you sit. But you put a rod on it or a stone over it, bomb. Right? So we have what is called as the mechanical interaction. But if I want to destroy it, just pour water over. Right? So we go over to the next, this one, right? So what is an explosive? I told you, which is a high energy material, right? So for us, it's a different, as Rani said, I told you, separate, science. I got induced into it. Again, with the help of Raja Saab and others, where there was an MOU signed between Gulbarga University and Premier Explosives Limited. What it is and all I will tell you. But, this was what an signature gave rise to a research area, because you are not allowed to do research of high energy explosives in as such per se in Gulbarga University or any other university. But with an interaction, you can use your ideas and give out and then come out with something else and all. Right? So fine about it. You have primary, you have a secondary. As the talk, I had to go into more of innovation. We'll go over to the next, this one, right? You can see the ACM. ACM is the particle surface phase, right? How the particles look like. See, beauty of our material chemistry comes in, which is Rani sir, which has got us introduced at University of Pune into material chemistry. In material chemistry, you start thinking differently than normal chemistry because your molecular weight changes when it goes to nano. You make a particle which is highly energetic to non-energetic also, per se non-energetic. Means a particle which is having sharp edges, it can break easily. When breaking particles, then it gives energy. Now, if I can round off the particle shape is, just which one is easier to break, a rod or a ball? Rod is easy or a stick is easier to break because it has a long axial ratio more. So, with an impact you can break it. Similarly is with the chemical bonds, right? If I can just make the particular material round shaped, or I can coat it with any of the coatants, then gone. You are retaining the energy, high energy, but you are making it easy for transportation, making it easy for a type of mechanical impact. Because whatever we talk about, when we talk about the high energy materials is I am going to take you to defense, I am taking you to space. There, they should not explode easily. They should have a particular retention power, mechanical retention power. That can come if I can round off. Right? I can show you, those are some of the pictures which are showing how to round it once. Right? Shall we go over to the next slide, please? Yeah. This is how very clearly you can see. RDX you have heard of? 6-membered ring. Right? And then HMX is also there. Right? You coat with and stearic acid, fatty acids, or you coat with a polymer, the mechanical stability increases, energy doesn't come down, right? Okay, shall we go over there next? Yeah, this can be, I don't know why this has come, Yeah, we'll not go into all this. One thing. Before this one. Yeah, I do not know about the time, how there should have been a clock also for me because being a teacher, I miss my timing, right? In explosives, you just let me see, tell, for our children. About when you go onto the road, you will be seeing a tankers on return, right? Highly flammable, be careful. Highly inflammable, be careful. Right? Everything irutte. Inflammable ಏನಪ್ಪ ಮತ್ತೆ flammable ಏನೋ ಸುಮ್ಮನೆ ಇದೇನು ಇಂಗ್ಲಿಷ್ ಬಂದಿಲ್ಲ ಅದಕ್ಕೆ ಅವನು inflammable ಅಂತ ಬರೆದು ಬಿಟ್ಟಿದ್ದಾನೆ. Is it like that? Or there is some meaning to it? In fact, there is certain meaning to it. Right? Inflammable once, then fire comes. Right? Just impact gives rise to fire. That is why we have to be very, very careful. Flammable means alcohol type. You catch a fire, it lit it, then it explodes. Right? So, there is a difference between the two. And this one also, I will just put a word to you that, what is the difference between these explosives and alcohols or petrol. Petrol is also an explosive because everything comes under this one. If suppose a car catches fire, what would happen? For our children, what would happen if a car catches fire? You can stand beside it or no? When a car catches fire, car is, petroleum, hydrocarbons. When they catch fire, you have to run. At least 100 meters you have to run. Because hydrocarbons are denser than air. As they are denser than air, horizontally they will spread. Because they spread horizontally, you have to run very fast, far off. Then fire extinguisher will come and all. But for this, high energy RDX and all, this is vertical. What do come out with RDX or HMX and all? It is all environmentally friendly ones. It is carbon dioxide, nitrogen, water vapor. So, what would the death occur? Death occurs because of large amount of gases with very high pressure, 8,000 millimeters per second. That's the strength it comes out with. So, you think what would happen? Apart from that, you can distinguish between a terrorist activity or an accident also. Right? It is just not I'm telling, because I belong to a particular, this one also I've been working, so I tell you I have a bit of responsibility also to tell that when there is a terrorist activity, you start seeing, you'll see that many of the scalpels, nails and everything are thrown out. Those are for destruction. They are on purpose kept. But with an accident, you will not see these nails and all, because this is an ESD option. ESD is electrostatic discharge and all. Okay, shall we go next, please? Yeah, forget about this one, because it's for this one. As I made my point that I have to go to the children level, right? We take about heat of formation. You have seen that in your PUC and BSc, you will be seeing heat of formation. Heat of formation, positive heat of formation is a very important thing, right? You used to work on ammonium nitrate. Ammonium nitrate is, be very, very careful about working with ammonium nitrate. Good thing is you use a OS, original solution, you put water in it. If you put ammonium nitrate in a glass tube and then heat it, never do that one. Any ionic compound, any nitro compound, add water over. Its sensitivity decreases. That's what I told earlier also, right? Shall we go, Yeah, this is one thing. Our professor from Japan is there, high energy physics. We are talking about high energy material, Cl20. Cl20 is such a thing, a very fascinating compound. You have a 6-membered ring at the base, 5-membered ring this side, both joined together, and nitro groups in the 6 positions, right? 2, 4, 6, 8, 10, 12, hexanitro, azizo-urzitane. That's a chemical name for it, but otherwise it looks like this. High strained compounds are high energetic compounds. If you can have this compound, it gives out a lot of energy. Again, you have to tame the compound. I have a ferocious dog. I can tame it by, having a belt to it. Right? The belt safeguards me. Similarly, we can safeguard this one because we need very, very high energy compounds. For all, now I will be going over to something actual application of the defense. Shall we go further? Yeah, you will see that how deep it can go. I wanted to show you with a simple example of having, you know about chapati? Chapati hit gurte large. As method hit madgare. I wanted to actually show you keeping chapati flour on my hand and allowing a knife to fall on it. You will see that it will not touch my hand. It will spill out. If I have a bullet, I wear a bulletproof for this one. What happens? The bullet will not go inside. It just lift it, get down. Anybody preparing chapati should be knowing this, no? Very clearly they will be knowing. What they know, when you are pressing the floor, you will see the rebounds. Your hands come back automatically, yes or no? That is what the rebounds action is. The molecules, they are rebouncing your action. This is what actually happens with your bulletproof also, right? Where it will not go enter into, right? I want to show with the knife, but okay, fine. If there is any possibility tomorrow there is a time, fine. Otherwise, I will send you as a video this one. Okay, fine. You can see that, how, penetration power, right? How deep the Cl20 molecule, if I can have, it can go into. That was shown with others and Cl20, right? Other molecules we have seen only as a ringed compounds. Cl20 and cubines you can see as in caged compounds. Shall we go next, please? If this can have in video, this one audio, this one would be there.
Chinese Academy of Engineering recently announced that China's new explosive, Cl20, has advanced the country's nuclear weapons development, placing China at the forefront of global ammunition technology.
How it goes into
this may seem surprising, as many people may not understand the connection between explosives and nuclear.
Yeah, I was telling about a bulletproof. With a bulletproof jacket, first this is over. But if I use Cl20 in the bullet, it can pierce through, right? Yeah, from India we have prepared a Cl20 at Premier Explosives. I think I can
Chinese Academy.
Infrared flares. This is one more interesting thing, right? I am just talking all these actuals. Infrared flares means what? Infrared flares are, sir, it is 10 minutes before, 5 minutes before I should be told that my timing, so that, I can, round up the things. Now coming over to infrared flares. right? Our physics people, know about infrared spectra. Chemistry also knows studies. I come over to this one as a black body radiation. In the black body radiation, we have studied, in quantum mechanics, wavelength versus absorption. It changes with the temperature. Right? The same thing happens. I hope then that one, I think if there is a video of the aeroplane. Yeah, you will be seeing the release of flares. What is that doing? It is telling it goes over to enemy territory and releases the flares. It tells I am coming, you can shoot me easily. Yes or no? I am coming over there, you can shoot me because I am releasing the flares, you can see where it is, right? It's not that, right? No fool will tell that way that I am coming to the enemy territory and releasing the flares. These flares are called as IR flares. The laser will detect those flares. It will not detect the target, that is the plane. The plane goes over, releases the bombs and then comes back. Right? It is like a decoy. It is decoying this one. Right? Of course, we had a certain accident. Abhinandan, right? Yeah, because the flares did not get released, the enemy found that, okay, this is a jet plane coming and they could hit it, right? So that's the thing which is, IR flares and chaffs, right? We work on a lot on these things, right? Yeah. Of course, what is the chemical composition of it? It's a magnesium, it is magnesium fluoride and some metals. Importantly, they use carbon. Why? Black body radiation again. Because your radars, which are IR based radars, they will detect the flares which is having carbon black body radiation. So target escapes out, right? Escapes out, bombs and comes back. Shall we go next please? Yeah, fine. Go ahead, that is the composition. Another thing is, why do we use dogs for detection of this? Explosives, one more thing as organic chemists or chemists know, that you can't smell, right? We can't smell. They are not volatile. When they are not volatile, when you can't smell, how to detect them? Because forget about the instruments and all, right? That's the next step. But detecting them becomes a challenge because you are not able to smell. First thing is, I just walk around the organic chemistry lab, I know that I am walking around the organic chemistry lab. If my wife or mother is cooking and all, I know that, there is a cooking going on. But here you can't. Dogs can sense, their olfactory nerves are very, very strong, they can sense. Coming over to dogs, okay, they are, fine about it, but they are also animals, they 15-20 minutes their power would be, afterwards they lose the power. What we want as a human being is to have a definitive method which will take care of detection very easily. In that came the thought of conducting polymers. In conducting polymers, the electron is more fissile, what Ravi and others also worked on. The electron is very, very fissile. Which electron? Pi orbital electron. Pi orbital electron moves easily. What is these energy materials? NO2 compounds. NO2 compound can attract. Electron abstraction is very, very easy. Electron abstraction is very easy. So the detection of this one with whether it's RDX, HMX, or any NO2 compound can be easily detected with a conducting polymer. Shall we go next, please? Yeah. Objective of sensing of high energy. This is a sensing, this one which people have studied, where you will see that because when an organic molecule takes in an electron, then what happens? Its sensing is studied. How do I sense the study? By fluorescence. Now here the comes of fluorescence, right? Not sure, 400, 500, something like that, that absorption frequency. You start seeing that the signal comes down and down. This is called as turning off effect. We have turning on effect also, where the, you add this one compound that is high energy, then the color comes. Here the color is fading. Color is fading, right? Where you start seeing the quenching, the limit of detection and so forth, don't worry, right? Shall we go next, please? Yeah, this has a slide, this sound.
10, 9, 8, 7, 6,
Okay.
5.
Sure. I just wanted to share because, from innovation, we have come over to now incubation. Now this is an industry. What in this, I am telling you about our Chandrayaan-3, which landed on the moon. And to the rocket, what you will be seeing is 3 or 4 rockets, first figure. You'll be seeing 3 or 4 rockets which are attached to it. You can just go.
4.
Yeah. You can stop it there where you can see that small rockets, the satellite side. They are called as cast boosters. They give a upward thrust to the rocket. Right? It goes. That is from our industry, Premier Explosives. Our industry means I was a director, then I am an advisor in fact. But it is on, from there it is this one, it's called as cast boosters. It gives an upward thrust for the satellites to go up. Right? So apart from this one, of course, you can fast move.
10,
Fast move. No, they are only fast move. You can put in
10, 9,
Uh,
8, 7, 6, 5, 4, 3, 2, 1, 0.
You can see the thrust, how much, then they get detached. In the
Plus
atmosphere
5
only they get
seconds.
detached. Right?
Lift off normal. P1
Here
seconds.
we have a majestic lift-off of LV.
Shall we go over to the next one, please? Yeah. These are all the things, you have heard of MRSAM, medium range surface to air missiles. Right? These RDX, HMX and all, where do you use them? Terrorists, forget about that one, right? You as missiles, short range within 50 kilometers, medium range up to 200 kilometers, large range to 1500 meters also, 500 to 1500 kilometers. You can have, even still higher, 5,000 also people have gone. You've seen the benefit of BrahMos also. And these are some of the things, part of the ones which come from Premier Explosives and many other this one, apart from this one. Of course, this is where I stand with the hierarchy of this one. Coming over to, as I told you that, about innovation, to an idea of incubation, because just everybody having innovative thoughts doesn't suffice. It has to lead to a type of incubation hub where there will be mentors, there will be mentees. Both join together, bring out the innovation in terms of incubation, and from this incubation, the next step is the business. Now, Government of India, fortunately enough, presently is working a lot and giving so much of benefits to the youth to work on innovations, to have their ideas turned into fruit as an incubation hub. We have, okay, some of the slides I just wanted to share with you. That is, this is, I am associated along with our Sampath Kumar sir on Three Cousin Lab. This is the government of Andhra Pradesh and government of Telangana have come forward. You can see some, the minister, this one, the last, this one, of course, he is MD, but the next to him, that white dress and all, as the politicians wear, he is the minister for excise endowments in Andhra Pradesh government, right? And others, even the, one is the excise head, what do you call, IPS officer who is heading that excise department of the government. He is there in the second photo. And then the collector. Both have come over, visited, because their interest is in the fruits. If you have seen, one small example, if you have, I have to share with you, is the mangoes. In the month of April, it was 140, 150 rupees kilo. From May onwards, you have seen 40 rupees down. Why? Because whatever mangoes have gone out, they got returned back. Why they have got returned back? It's not the first time, first time got returned back. We have been sending, but this time they say that, you have not screened it for UV. Some reason they want to say. And then who is hit? Our farmers. Our farmers is hit, our politicians are hit. Our politicians are hit means our economy is hit. So 40% of the fruits are going as a waste. So you have various ways of doing, converting the waste. If it is a spoiled fruit, you can have a bio-compressed gas coming out, right? You can make it. But for the fresh fruits going waste, then comes the challenge, right? So this fresh fruits, we all know, as chemists, what do we know? Fruit has sugar. Sugar can be converted to alcohol. So this is called as, and alcohol has its own benefit to the economy. Don't worry about, I'm not talking about the, Iraq and all. These are called as crafted spirits or the artisan spirits, which are higher end, flavored with a particular taste and all. What we have here is, right, you can have the conversion to alcohol either chemically or you can have biochemically. And microbially, wonderful. We worked it out with, you can see that how Sampath Kumar sir is, showing exactly the fermentation. Right? I'll go over there and then. This is how you can see how the research scientists are trained under fermentation. Next goes to the distillation, and you see the distillation. Right? You have the visitors also. Right? Rane sir is there. There are many others who have visited. And we have shown you in the flavor, different flavors, how they. This one. We had a talk also about the Goan gin or feni, right? But here, this is the tomato first thing, right? Because, Madanpalli region of Andhra Pradesh has a full growth of tomatoes. And much of the tomatoes are going waste, right? Not that, we want hundreds of people to come over and take over to benefit the farming community. So alcohol is one thing, but this is a superior grade alcohol, right? So I am not showing you the exact thing because this is a business model. So I will have to restrict myself into only the glimpse of what is happening. This alcohol should not contain any methanol. In the spirits from US and European Union, we have 2% methanol. Here with this one, 0% methanol we have got in R&D, which is going to be scaled up possibly the same way. Right? And the other flavors what you get is from the esters. You have to retain the esters. Right? This is what I bring to you, the youth, that you start thinking. Thinking should go to working. Working should go over to manufacturing. Right? Just, thinking in air and saying that we are big, we know this one, we know, I can write example. Or, sir? Yeah, I write exams and all, I write a first rank and nobody bothers. Now I will tell you about being a teacher myself. I will tell you very clearly, don't bother about your ranks or your gold medals and all. Those are for a showcase, for media to take the benefit, for us to have a present thought that, okay, I have a gold medal and all. But if we don't take care of our knowledge, we are no way. Shall we complete this? Okay, I wanted to tell you something more about, how Indian science. Many of you have worked. You have told how, in our ancient this one, we have worked out and all. Right? You see the statue which is now getting decolored, right? Whereas our iron pillar is still strong, right? See, what we have is not from copper. We have from bronze. That is why our gopuras and all are still stable. Go over to the other this ones. You have the same way where our strength of our science was there. We appreciate, we have to think high about our science, but understanding it in a proper way. I think over, no? Yeah. Yeah, I thank all of you. I thank my sir who has given me and a wonderful chance for all of you to make him as my chairman of the talk. I thank all of you. Thanks, sir, for agreeing to, my request of being dedicated this talk to you. Thanks. Thank you all.
Thank you, sir, for your great talk about a new dimension in material science. And high energy materials are revolutionizing material science with their unique properties designed for energy harvesting, storage and conversion. So these materials, including advanced batteries, superconductors and nanomaterial like graphene, merge chemistry, physics and engineering to create more efficient technologies for renewable energy, electronics and aerospace. Thank you, sir, for your dynamic speech. And now I would like to request Dr. K.S. Rane, sir, to propose vote of thanks to this plenary session.
Yeah, before giving a vote of thanks, I think this this conference is for not only for chemistry people. And his talk is now, especially about the explosive, if a chemistry person can pose 100 odd questions to him. But the way he brought it, the terrorist is a different cup of tea, and the same chemical we are using for the benefit of the society. That's what he wanted to tell us. Because if the chemistry is in the wrong hand, what can happen? And if it is in the right hand, what will happen? That's what he wanted to put it before audience here. Thank you very much, Professor. Especially about somewhere he, Vranda may object me, he brought a penny. That there is, I was there, see what the spirit they have produced is a zero methanol, 0% methanol. Now how much methanol is there in your penny, your means, I mean Goan penny, you try to find out about that one. Okay, thank you very much.
Thank you. In a fraction of moment, so definitely we will have to start the second plenary session. So this session is really curious because already we know that afternoon session is just like nodding, but also definitely he will have to make us to awake. And ready? Okay. So Dr. H.M. Sampath Kumar, MSc Organic Chemistry from Gulbarga University, securing gold medal in 1986, PhD in Bioorganic Chemistry in 1995 from CSIR, Indian Institute of Chemical Technology, Hyderabad, and government involved in developing indigenous technologies for agrochemicals and pharmaceuticals products, and trained at Advanced Chemtech and Louisville, USA on combinatorial chemistry and solid phase synthesis and high-speed robotic parallel synthesis. And actually he has really a great biodata, and I think this is not enough time to read out these all things too. So, but we would like to listen his voice, and then we can easily understand that how important the person is. Sir, I would like to invite you to the dais, and you will have to address us, and the dais is over to you, sir.
Before he starts, I'll just make one small presentation to you. Our Sampath is from Karnataka, so he will also be, communicating with you in good Kannada, plus English, and you are free to ask questions also in Kannada. This will be the most exciting talk you will be hearing, much touching our lives, right? And I request the students to come front. Right?
Thank you, Professor Venkatraman, my dear friend. Unlike great professors, in the inaugural session, we had 3 great talks, 2 stalwarts from India, very great scientists whom I revere, Professor Raja Saheb and also Professor Naik. Out of their experience, they talked extempore on how science has developed and how science can open up opportunities for youngsters as the career option. So it was really disheartening to know that more and more as the year passes, number of students who are getting enrolled into science, the number is dwindling. That has been happening since almost 10 to 15 years. Hopefully with great visionaries like Professor Raja Saab, and also, Professor Naik and many more, stalwarts in India, there should be a change in policy making so that, students should get enthused and to take up this science as a career. It should be reassuring to them, not only in terms of the, getting a job, but also from curiosity and also knowledge and societal benefit point of view. And again, we had one more great presentation, very lucid presentation by Professor Venkatraman and I am sure I am not able to compete with them. And he has been doing a great service to nation, defense, ISRO, and also to various other countries. Very great work. We are all proud. And when I started my MSc career way back in 1984, my brother sent me to Professor Raja Saab, who had taken up the faculty position in Gulbarga University. With his blessings, I started my career. Actually, my scientific career started right from BSc, of course, but I did my MSc chemistry from Gulbarga University. I am truly proud that Professor Raja Saab is now the chairman of Karnataka Science and Technology Academy. I think with your vision, we will have great opportunity in Karnataka as well as outside, as far as, furthering the science goals of, youngsters, sir. With this brief introduction, I will quickly go through the slides. Actually, I was cautioned by Professor Nayak that, I should complete this within 30 minutes. Fine. So, I will be talking next, my narrative will be mostly on the advancements of human vaccines, how exactly, mostly focusing on the COVID vaccine development because it is very relevant for today. And I was fortunate to be part of this, vaccine development in India as well as abroad. And I worked with various, major vaccine industries like Bharat Biotech, BioVet, and also Gavi, European Union, on the development of influenza vaccine. Next slide, please. I think somebody's, can I have next slide? Okay. We are going through an era of, excitement and agony. See, on everyday basis, our lifestyle is changing. We are adopting newer and newer technologies. And we are also having a lot of distress. Next slide. Some are man-made, some are influenced by human activities, some are natural, and some you never know, like COVID. Who brought it? We never know. Next slide. COVID has engulfed this, planet in a lightning speed, and it started in November 2019, and within 2 months, entire globe was covered with COVID, and it slimed almost 1 in 100, around 7 million people were killed out of 700 odd million infections. And it posed an existential threat to human beings, which was very devastating. And quickly, with a firm resolve at an individual, institutional, country, government, and also at the global WHO level, very focused, dedicated, effort led to the discovery of several vaccines within a very short period of time, which we never imagined. Because if there is a threat, definitely, you need to work for your own survival. That's what happened. And quickly, COVID surged back. And it is there in the background. It never goes, and virus is mutating fast. But whenever there is mutations, virus gets weakened or strengthened. That is our luck. Next slide. No doubt, vaccine development has, saved millions of lives, millions and millions of, scores of unnecessary hospitalization was averted. This planet has become a safer place to live in. Our life expectancy has gone phenomenally up because of vaccines. Next slide. Can I have next slide? I'll say next, you can, yeah. See, these are some of these, how vaccine has protected, to almost to 100%, like smallpox, polio, all these are eradicated. Professor Raja Saab has, explained it in a very, very lucid fashion, how these Edward Jenner and, his efforts led to the discovery of smallpox vaccine. Next slide. Next. Click it, yeah. But in spite of this, we have very effective vaccines for all these diseases on the left-hand side. On the right-hand side, we have lot many diseases you don't have vaccines, or you have vaccines, but they are not affordable to the poorest of the poor on the planet. Except, this accounts for almost 40% of all deaths below the age of 5 years children, and 60% can be averted if we have vaccines, except barring malaria, TB, and HIV. Vaccines are there, but they are not available to poor. So it is not only the, making of effective vaccine which is important, but also making it affordable and making it in right number of doses so that, all, the entire population in the world is immunized like how we did in COVID, so that, this can be, the disease can be eradicated how we have eradicated smallpox or polio. Next. Vaccines, why it is difficult to, Jenner developed vaccine on smallpox, polio vaccine had been developed by Salk and Sabin, and, several other vaccines have been developed. Very successful protection, 100%. Why we are not able to develop vaccine for TB, effective vaccine for TB, dengue, and several other diseases, HIV? Because pathogen poses a great problem. It is not straightforward science. There will be, there is a continuous evolution and competition between microorganisms and this host immune response, host immune system. They are co-evolving continuously, and seeing each other's strength and weakness, they are evolving. They are checkmating each other. There will be immune evasion. Pathogens are known to evade the immune system. There are also multiple serotype problems, like, in case of dengue, there are several serotypes. If you develop a vaccine against one serotype, it will not work for the other serotype. There is antigenic drift. For influenza, it is not a big killer in India, but it has been a major killer in Western countries. So, antigen keeps on changing. It is like a shape-shifting demon, so it keeps on changing every winter. So, then moderate to limited efficacy in case of COVID or influenza, short duration of protection again in case of COVID, complex life cycle, like in malaria, the malarial parasite has a very complex life cycle. We don't have effective vaccine against malaria. We have been trying to develop malaria vaccine, but word is not successful. There are some candidates, but they are not true vaccines. So these are some of the challenges. Next. Excuse me. Yeah. When I was in second BSc, I had been a voracious reader of other than science. So one day I was reading the Reader's Digest. There is a book chapter in Reader's Digest. At the end of the Reader's Digest, a small, giant little volume, Reader's Digest, there will be a book chapter. In that, there was a book section called Body is the Hero. I was curious, what is it? So I read it, around 50 pages or so. Amazing, those days immunology had not developed so fast, and so much information was not there. But Ronald Glaser has brought out, in a vivid description how these immune cells, fight with each other and, with the pathogens, and how they protect our body. So he says it is not the antibiotic or it is not the vaccine which is the hero, but body, means immune system is the hero. Next. So immune system has, there is a complex orchestration and interplay of, between these cells. There are very specialized cells which are on the left hand side, which are like foot soldiers, which clear the pathogens instantly. And also they study the pathogen, the structure, and they design the chemical weapons, how Professor Venkatraman was showing missiles, heat-seeking missiles and all. Similar to that in our body, they design chemical weapons like antibodies, chemokines, some of the cytokines, cytotoxic T lymphocytes, and they exactly act like heat-seeking missile. They chase the pathogen and kill it. So this right-hand side is called adaptive immune response. It takes sufficient time to develop adaptive immune response, and it has a memory. That means once there is an infection, and body or immune system will remember this pathogen for the lifetime, And whenever there is an attempt by this virus or a bacteria or whatever pathogen to attack the body, our system, then there will be it will surmount tremendous adaptive immune attack within very short span of time and neutralize this virus or the pathogen. Next. Next. Next, please. So, adaptive immune response has several stages. But if any of the stage, if virus is capable of deceiving our immune system, it understands. Remember, virus is more evolutionary point of view, virus is more evolved than our own cells, because it has uncanny ways how to understand the immune system, how it works, and then checkmate. So any attempt by the virus to bring down some of the stages, our vaccine or our immune response will fail. Next. So I don't want to say, Professor Raja Saab said, this how Jenner, who is called as father of vaccinology, how he has injected the exudates of cowpox virus into this boy of 8-year-old, and how he didn't get the smallpox. So this was the finest example. It was not a discovery of serendipity. It was a discovery by Jenner through close observation. How he has observed what is happening, and through observation, he has developed this, this so-called, what you call, it is not an attenuated one, it is called cross protection. So how cowpox is able to protect us from the smallpox. Next. See, most of our age group, we have big scars on our left arm, because it was called as not vaccination, it was called as inoculation. They used to puncture not less than 20 times, it was very painful, and taking the vaccine itself was so painful. They used to heat that needle and puncture it several times, and each one of us, Professor Rane, we have big scars, but you children, you don't have those, because now vaccinology has evolved. So it has become like, intradermal and subcutaneous, and injections are very fine. So you don't get this scar. So it was Pasteur, to commemorate, discovery by Jenner, who named it as vaccine, derived from the word vacca. Vacca means cow. Next. So Pasteur, discovered rabies vaccine because, he attenuated, weakened the virus of rabies in the brain cells of rabbit. That's why it is called as rabies vaccine. He has done several passages, means he has, infected the tissue of rabbit, brain, and he has isolated this and again infected. Hundreds of passages, he got a non-virulent strain which was made as rabies vaccine. Same is the case with cholera, more or less the same time these two are evolved. Next. When, in case of live attenuated or weakened vaccine, which uses whole virion, this virion, this genome is, it mutated by growing it in an altogether alien tissues, so that, the virus has the capability to sample the genetic material from the surroundings, and as it acquires more and more alien genes into it, and its virulence goes down, and whereas it will have all the antigenic properties which can stimulate our immune system, and it can activate some of the bystander immune cells, so that you can have antibody and T cell response. Nowadays, after COVID, every common citizen, be it arts or even unpad also, they are talking in terms of T cell response, antibody response. More or less, world has become, most of the people have become immunologists. It is surprising, because they say antibody is not there, T cell response is not there. I used to hear this in marketplace. So very nice. Earlier we were only talking, immunologists used to talk, microbiologists used to talk, but now common man is talking. So yellow fever vaccine by Thielen was also developed, millions of lives saved, through attenuation of yellow fever vaccine in chick embryo. Through 170 passages he made. There 170 times he infected different tissues of chick embryo and isolated a non-virulent strain. Next. It is the Salk and Sabin who discovered polio vaccine, two different varieties of polio vaccine. One is inactivated vaccine, one is active, this attenuated vaccine. Both started more or less same time in US, but Salk, quickly could collaborate with some of the multinational companies because they wanted to grow virus in large quantities. Only big industries can do that. Same happened in COVID also, where how Bharat Biotech could develop vaccine. Why nobody could, other people could not develop it, but in Asia, except in Russia, but why Bharat Biotech could develop? I will come to it little later. Salk developed it, and with the help of multinationals, they could inject to millions of children, and 90% protection it offered. It is an injectable vaccine. It is a dead virus vaccine. If you inactivate the virus with chemical, heat, or a surfactant, and it loses its, of course, it is killed and it cannot replicate, then it can be antigenic. It stimulates our immune system so that whenever there is an infection by the same virus, our immune system will surmount an attack. That is called immune response. Whereas Sabin strongly believed the story of Pasteur and Thiele and Jenner that live attenuated virus can only give long-lasting memory response. That means if you take a vaccine, it should be reassuring, lifetime you should not get the same disease. And there should not be any event of taking vaccine again and again and again, pointless. So he thought that only live attenuated. Attenuation means weakening the virus. Art of weakening the virus, making it non-virulent is called attenuation. He attenuated this poliomyelitis virus in chimpanzee or monkey cell lines. Hundreds and hundreds of times he passaged and he got a non-virulent style. Next. So what happens? Salk's, both these great scientists' effort led to the removal of this virus from the planet. Now there is no polio. But we have the genetic information, we can create this virus again, but deliberately, but it is not existing. In Salk's, Sabin's vaccine, actually poliovirus enters our body through mouth, and it goes and attacks the intestinal mucosa, and from there it goes to the brain and attacks the brain. Okay, so now Sabin's vaccine, attenuated vaccine, can protect the intestinal mucosa so that it is far more superior compared to the killed virus or injectable poliovirus vaccine developed by Salk. That is how whole world has adopted Sabin's vaccine. And now next slide. This is how all three different wild strains were attenuated, and they got Sabin developed this polio vaccine. Next. So if you see on the top right hand side, the graph shows that in the killed virus vaccine you have to take the booster dose again and again to have protective immunity. Whereas in case of live attenuated virus, you have couple of doses, it will lifelong immunity it gives. That means it is far superior. Here, live attenuated vaccine on the downside graph, it offers 100% response, protective response. Next click. But the problem is virulence. If you take a vaccine, even 1 in 1 lakh or 1 million people also got the same disease because he has taken the vaccine to protect it, then it is highly unethical and it is not acceptable. There is a possibility that weakened virus can get strengthened in some of these immune compromised patients, so that that becomes virulent. And also live virus, you need to carry it, you need to store it in fridge. The virus is not, it will not survive at room temperature. Particularly this is very relevant because earlier days there was no electricity in poor countries like continents like Africa, or even developing country like India. Rural area there was no electricity, so storing, having a fridge and all was unthinkable. So these are some of the drawbacks, and also transmission to this non-human host and again getting transmitted into the humans. These possibilities are there in attenuated virus. Per se, both killed virus vaccine and attenuated virus vaccine, though they were very effective in removing the polio from the planet, it is not acceptable for today's, from today's point of view as a safe method of developing vaccine. Next slide. So what people thought of, simplifying this virus, bacteria, fungus or whatever pathogen, and they started taking smaller part of this, pathogen and using it as an antigen. When you start, simplifying, purifying and, these pathogens, its antigenicity is compromised. Once antigenicity is compromised, you need to compensate the loss of antigenicity by adding an external immune potentiating agent, which is called as adjuvant, which is my area. For your information, through the help of various agencies and funding agencies, DST, DBT, and of course CSIR, I established a state-of-art laboratory in India, which is a national facility for vaccine adjuvant research. Much before COVID, we foresaw the requirement for developing adjuvant almost 10 to 15 years before COVID outbreak, and which came handy, which was very useful when we had to develop vaccine against COVID. Next. In spite of all this, this shows that antigen takes the center stage, but it is a immune potentiator or delivery system which is put together called as adjuvant on the right hand side, which decide the affordability, feasibility, safety and overall efficacy of the vaccine. That means vaccine success is guided by the complementary adjuvant that you use. And it skews the immune response towards T cell response complementary to the requirement level, so that we can get a prophylactic threshold. That means protective immune threshold. Next. So the adjuvants also address some of these pathogen related challenges which I was discussing earlier. Next. So if you see this, right from 1750 up till now, more and more of these red dots are vaccines without adjuvant, and the ones which are blue dots are with adjuvant, which clearly shows that after 1980s, slowly non-adjuvanted vaccines are being replaced with adjuvanted vaccines. Next. So, next. These are some of the what are those adjuvants? They are the immune potentiators which can elevate or enhance the immune response of a vaccine antigen, and it can be an inorganic salt. Actually, aluminum hydroxide, is also an adjuvant, which was only US FDA approved adjuvant till 2000, because adjuvant research was very slow, and people thought that is good enough, alum is there, no, it is very cheap and we can use it. There is no need for other adjuvant. But this mindset has become a roadblock for vaccine industries from developing, major vaccines for other diseases like TB, malaria and others, because alum could not, serve the purpose. We had lot of antigens, which is called as subunit antigens, but we didn't have effective complementary adjuvant. So then came several other, adjuvants which are called as T helper cell 1 adjuvants, whereas alum is a T helper cell 2 adjuvant, and it is a very complex one. I am trying to oversimplify the story. So there are a lot of emulsions, nanoparticles, and oligonucleotides. Different structural class of molecules can serve as adjuvants. Next. So these are pathogen associated molecular pattern. Pathogens carry molecular patterns outside, and these molecular patterns are sensed by immune system. Immune system recognize, like a barcode reader in a supermarket, immune system recognize and read these patterns of molecules on each pathogen, based on which immune response sets in. Now what we did, we have isolated this pathogen associated molecular pattern, we synthesized them, we generated the library, and we have tested them for their adjuvanticity. These are called as PAMPs. Next. And these are natural products. They are isolated from plant. This is the top one is called Blackbuster saponin, which is used in Covishield vaccine. And in the first dose of Covishield, most of 80% of Indians have taken Covishield from Serum Institute, which was basically developed by AstraZeneca and Oxford, and which was available in a large quantity in India by the effort of Serum Institute Pune. So they were using this adjuvant, which was, imported from USA. Once the first dose was administered, US Biden government has put a blockade on this molecule. They said that, this plant, you are over exploiting, there will be a large scale deforestation in South America. Actually, they are not getting from USA, they are getting from Mexico, but, USA had a problem because they wanted to further their own vaccines. So they blocked it. So that was a big problem for second dose, and they had to adopt, some other adjuvant. And the second one is from a sponge, deep sea sponge. And third one was we extensively worked and used it in Covaxin, which is a synthetic molecule. Next slide. In all around, in our laboratory, we synthesized 450 novel adjuvants, tested them. Next. And these adjuvants establish effective communication between antigen presenting cell. That means the immune cells, the crosstalks between the immune cells, and it's a very deep mechanism, so I am oversimplifying again. So, and then it leads to antibody response and cytotoxic T lymphocyte or T cell response. Next. Click it, please. Okay. This adjuvant research involves, lots of ex vivo, in vitro, ex vivo, in vivo, these studies. Next, click. Go on clicking, please. Yeah. So, click, please. Next. So, in vivo studies, and we studied, please go on. Antibody response, surface antigens, and how some of the surface proteins will influence the immune response. And all these things should be studied properly vis-a-vis the antigen, and we have to finally select this adjuvant is suitable for this antigen, so we can develop an effective vaccine. Next. Again, you have to go for all sorts of mechanistic studies, in vitro toxicity, long-term, this repeat dose toxicity, single dose toxicity, and all. Click. Next. Yeah. Now this is a very important slide. Traditional vaccine development takes 10 to 15 years. That is how world was working. Discovery stage to this, when it comes to market, it will be not less than 10 to 15 years, shortest. It is like running a marathon. Click. Next. Yeah. Because there was a threat, we accelerated, this was called as, there was a surge in the invention. So the acceleration of, phase of, vaccine research, so that, entire vaccine discovery could be completed within 1 year. And we started within 1 year, we have the vaccine. We had the COVID in January 20, we have vaccine in December 20. So it was amazing. If the speed was not there, I think half of the population would have been, lost. So that speed was very, very essential. Thanks again to all from individual to global level concerted effort. So selfless, dedicated, effort from scientists and all, around, this is not only scientists, led to the discovery of vaccines. Next. So this is how it happened within January to December, how, mRNA vaccines were discovered in the West within 1 year time. And much before this, we had live attenuated and, inactivated, of course, inactivated vaccine. And also, this Covishield. Next. See, SARS-CoV-2 is a single-stranded RNA, enveloped RNA. Click. So, which is the spike protein has a, that is called, down. There are S1 and S2 region, and these S1 and S2 region of the spike protein should be broken. Only our host, protease has the capability to break it. That means SARS-CoV takes the help from us and harms us. It takes the help, it harvests the enzyme, that is a protease from our own body, and it cleaves this S1 and S2, and next. And then it attacks this angiotensin converting enzyme receptor, which is everywhere. It is available in our body everywhere, not only this, nasopharynx and also, heart and various other things. So next, once it is infected, then, it enters the cell and, it starts replicating. Now, these are some of the vaccines developed in India, world over. They belong to, these viral vector vaccines and inactivated, virus, and also protein antigen based vaccine and mRNA vaccine. These are different strategies for achieving the same goal. Next. These were some of the vaccines which are made available in India. And Covaxin, was our own homegrown vaccine by Bharat Biotech, and Sputnik came from Russia, and Corbevax came from biologically. We were also collaborators to this, and Covishield was developed by Serum Institute, Pune. It was discovered by AstraZeneca, and other things, are shown here. Next. So, how exactly this, immune response takes place? When COVID attacks, and there is a dendritic cell, which this virus enters the dendritic cell, click. Then go on clicking, yeah. Then click it, yeah. Go on clicking. So once it enters, it processes the virus and present it to T cell, T helper cell, and it becomes divided into T helper cell 1 and T helper cell 2 response. T helper cell 2 in turn, go back. What happened? T helper cell 2 will generate some of the cytokines which activate the plasma B cell, and the plasma B cell will lead to this potential antibody response, which is called as neutralizing antibody response. These antibodies come and sit on this virus and bind to them, which is called as opsonization. And once they are opsonized by antibody, there is an envelope of antibody around the virus. Antibody will not kill, remember, antibody will never kill the virus, but it opsonizes. Once it is opsonized, our body immune system, which are called as macrophages, are capable of, detecting the hinge region of these, antibodies, and they come and engulf and kill the virus. Whereas in other arm, T cell, T helper cell 1 response, which is also called as, inflammatory response, there cytotoxic T lymphocyte is generated. It is exactly like what Professor Venkatraman has shown, which is like a heat-seeking missile. Once cytotoxic T lymphocyte is initiated, it goes, chases the infected cells, which are the breeding ground for, other virus. Virus will enter the host cell and it will replicate, prepare copies, hundreds and thousands of copies of virus, and it will burst and come out and again infect the surrounding cells. This cytotoxic T lymphocyte will detect this infected virus and lyse it using chemokines and other inflammatory markers, so that that is how protective immune response is established. Next slide. Next slide. Go on. Next slide. So this is the Covaxin story. Inactivated Covaxin, the SARS-CoV-2. Again, SARS-CoV-2 had to be available, like in case of polio, in large quantity. In India, we didn't have the capability to have this containment. Containment means these are the BSL-4, biosafety level 4 virus. You cannot grow it outside. And if you grow large quantity of virus, it will spread. In case, it is contaminated, somebody will carry it, and, it becomes a bomb. So, like a nuclear bomb. So, you need to have a containment. So, luckily, thanks to the vision of Bharat Biotech leader, Krishna Yella, he has developed way back in 2015, BSL-3 containment facility for some other like rotavirus, what Professor Nayak was mentioning, rotavirus and, other viral vaccine, but it was lying idle there. But it was very expensive to have large manufacturing facility, but he was maintaining. In Southeast Asia, Asia Pacific region, it was the only containment facility, BSL-3 containment facility for the manufacture of vaccine. So, virus, containment of virus. So, NIV, National Institute of Virology at Pune, which is an ICMR lab, had a BSL-4 small containment facility which they have developed this, SARS-CoV-2 virus in a sizable quantity and transferred this to Bharat Biotech. Bharat Biotech produced it in large quantity and they developed the inactivation. And we from IICT developed, the TLR7 agonist for this in collaboration with US, our friend, Sunil David in USA, good friend of mine. So this molecule has several hydroxy. It is having a gallic acid moiety which can complex with alum, the aluminum hydroxide, and it offers a very powerful, NLRP3 response, TLR7 response, and also it simulates the disease condition. That was the success. The combination of the inactive virus and the adjuvant was the success for Covaxin. Next. Next, please. So next. Go on. Yeah. Even Prime Minister has taken this vaccine, and it was tested first, the phase 1 in dozens, phase 2 in around 360, phase 3 around 38,000 people were tested. Next, click it, go on. Yeah, we also developed similar to this, the TLR7 agonist what has been developed. So we also developed it and, we transferred this technology to European Union for the development of, this influenza vaccine, and 7 countries are working on it. Some of this, click it again 2 times. Yeah. Next slide. Next. Next, please. So this is the indigo. You must have heard the very famous lady, FRS, only FRS in India, Professor Gagandeep Kang. During COVID, you must have seen every day-to-day basis on TV. She was the director of THSTI, and in one of my presentations in National Institute of Immunology, she said we will, based on my presentation, we had a lot of adjuvants. She thought, we should work with them, and, that is how we developed a collaborative project with all these institutes in Europe as well as in India. And IICT provided these adjuvants. Next. Next. And not only this, during COVID, quickly, there were lots of requests from not only Bharat, but other industries also. They didn't know which adjuvant. We had library of adjuvant, we had facility to screen them, everything end to end, which was developed with a forethought almost 10 years before COVID. So they said, they came to us, they said, can we test what is complementary to COVID? Because earlier we were testing with Japanese encephalitis, hepatitis B, dengue, chikungunya, and all those viruses, but we never tested on SARS-CoV-2. So we got the SARS-CoV-2 virus, and we tested some of the adjuvants we had, and we found which is showing highest antibody response and T-cell response. We transmitted this information to industries, 4 major industries, which has helped a lot in finalizing their formulation. Next. This is Serum Institute, Adar Poonawalla, and how the viral vaccine, non-replicating viral vaccine is introduced into a adenovirus, and once adenovirus enters the antigen presenting cell, it processes and presents this protein derived from this genome, and it activates both arms of this antibody innate and adaptive immune response, and humoral and cell-mediated immunity, and it is the most effective vaccine. And you can see in India, most of us have taken Covishield. And around, you can see 351 million people got vaccinated with Covaxin. And I think more than 1,000, I don't know, I am not able to read that number from here. So they were administered with Covishield, and others will come, far behind these things. Next slide. Yeah, I'm finalizing. So this is a recombinant vaccine, what has been developed by Minvax and biologically. Next slide. Yeah, this is a spike protein. They developed through a recombinant technology, through plasmid. How they have. Next slide. Click it. Next. Next, please. And they have taken this, the plasmid from E. coli and introduced the gene, and they developed the recombinant technology, and the protein these RBD proteins were generated and purified, and they were used. Next. And they used complementary adjuvants. Some of our adjuvants they used for developing these recombinant antigens, antigen-based vaccines. Next. These are two of my best friends from IIC Bangalore who developed first vaccine in India or Asia Pacific. 2020 February their vaccine was ready, but unfortunately they were collaborating with us as well because they were the small company. They could not see the light of the day. Their vaccine can withstand 100 degrees centigrade. It is a far superior vaccine than any of the vaccines available on the face of this earth. But hopefully if there is a COVID outbreak next time, probably they will be able to manufacture it. Next. This is the mRNA platform, a very famous one. How mRNA is introduced into, lipid nanoparticle and introduced into the cell, and it self-replicates and generate, most of these surface antigens which elicit antibody as well as T-cell response. Next. And mRNA vaccine has become far, far popular because it is very easy to manufacture mRNA vaccine at large scale compared to any of the other inactivated or, other vector-based vaccines. Next. See, this is the last slide. I think probably this is an answer to, and that's not an answer, but that's, my comment will be complementary. As you keep on climbing the educational ladder, you tend to lose some of very favorite subjects. For example, from primary school, somebody may be interested in history, but you want to pursue science, you forget history. And you go on. As you move on up to post-graduation and beyond, up to PhD, and you keep on going in a reductionistic approach, you keep on learning one topic. And unfortunate thing is, down the line, you lose the flavor of what all you learned. This is it's a tragic thing. Because if you want to develop a technology or a product, it be a drug, vaccine, or a space technology, or a missile technology, what Professor has shown, so you need to leapfrog the information from subject to subject while gathering all the knowledge and assimilate it and translate it into technology. But unfortunately in the today's education system, we need to give a sort of an encouragement to carry all this knowledge gained over a period of time, right from your primary schools up till your post-graduation and beyond, so that you can apply it to the development of some of the best technologies in the world. Next. These technologies are making us more and more dull. They are no doubt good, but you are becoming a parasite. And without that, imagine a day if I snatch your cell phone, what happens? And can you imagine your life without cell phone? So next, see, these are the rishis of vaccine development. Jenner, Pasteur, all these great scientists who discovered the polio vaccine and yellow fever vaccine. I remember this, from Dara Bendre. We need to get connected. We need to get grounded to earth, but you should do blue sky research like what Professor was showing. Then only best technology is possible. If you forget your history, forget the knowledge you gained painstakingly throughout your education, then probably at the end of, when you want to really deliver, you will not be able to deliver. Please, for the sake of knowledge, you retain all the things. Don't hear from here and forget after writing the exam and, next day you ask and you don't know the answer. Please don't do that. Please remember what all you learned and carry it, be it arts, science, mathematics or anything. Any science is a cloud science. And you need to know everything, little bit of everything to develop a product. With this message, I thank you all, and I've taken a little bit more time, Professor.
Thank you, sir. Human vaccine development has evolved from traditional methods like live attenuated and inactivated pathogens to modern approaches such as mRNA, viral vectors, and recombinant DNA technology, enabling faster, safer, and more effective vaccines. These advancements have celebrated response to global health crisis like the COVID-19 pandemic too. And thank you, sir, for giving a great ideas about these vaccines. And now I would like to call Dr. Venkatraman sir to conclude this plenary session and propose vote of thanks to the resource persons too.
Thanks, madam. It was a very exciting journey
from our Gulbarga University student, right, to a great scientist who has worked for humanity, who has worked with all his dedication and passion, who has worked for seeing that humanity sustains. And on behalf of RSC, sir, on behalf of all the staff here, and if I take the liberty on behalf of our Gulbarga University, we thank you immensely. We congratulate you for the rise you have gone through, for the challenges you have overcome, for your societal benefits you have given to all of us. We immensely thank you, sir. Thanks.
Thank you, Venkatraman sir also. And now we would like to move the next session 2 in the first lunch break. And this one is Dr. Yuri Petnev's